A very good afternoon, good evening to everyone from Hindustan International Schools. Welcoming you all to another very intriguing and wonderful session of HIS Ignites Minds. HIS Ignites Minds was started with the purpose of inspiring the young minds to meet people of value and wisdom and gain a sense of clarity over their conflicts and confusions. That spark can be lit only by a book or an individual who has experienced success the hard way, and the lessons to be shared can be a path for many. Our director and CEO, Dr. Anand Jacob Varghese, has always been supportive on initiatives which encourage and enhance the capacities of the students. True to the philosophy of the school, to make every child a success and no child a failure. This evening, it is indeed a pleasure to welcome the very popular, self-made and enthusiastic, the Tamil Nadu weatherman, Mr. Pradeep John. His social media handles are full of visitors eager to know and understand the weather and climatic changes. The most interesting part is the detailed analysis. Mr. Pradeep John, hearty welcome to you. Talking in brief about him, a little introduction. Mr. Pradeep John is the son of Mr. G. Ramachandran, who is a retired municipal commissioner, and G. Monica Arasi, a retired headmistress in higher secondary school, Government of Tamil Nadu. He was born in Kanyakumari and has settled in Ananagar in Chennai for the past 35 years. He has a beautiful wife, Hana Shalini, and they have a lovely daughter, Laura Abigail. He is presently working as a manager in TNU IFSL Quasi Government Company under the project development sector for the past 10 years. His bachelor's degree is in computer science engineering in the year 1999 from Satyabama Engineering College, followed by an MBA in finance in 2003. He has always been a pluviophile, and we all know what that means, a lover of rain and the rain which gives all of us happiness. The significant cyclone which made landfall in Chennai in October 1994 and the subsequent floods in June 1996 created huge interest in weather in him. Even though his education, BE in computer science and MBA finance, has nothing to do with weather, he continued his passion during his free time. He started giving real-time weather updates to the people on Chennai and Tamil Nadu weather as the Tamil Nadu weatherman from 2014 in Facebook and Twitter. He was part of the important weather events such as 2015 floods in Chennai, Cyclone Varda, Cyclone Oki, and Cyclone Gaja. In 2018, he was awarded the prestigious Pride of Tamil Nadu award for his contributions under the social impact category and received the Inspirational Role Model Award at CII Connect 2019. And we wish him many more accolades and success all his way. His aim is to make common man or farmers understand the weather pattern and causes for rain, importance of water harvesting in our basin, and use simple terms and pictorial representation of weather charts using the social media. And also to quell rumors at the time of disasters. That's heavenly. As on date, he has 8 lakhs plus followers on Facebook, 3.5 lakh followers in Twitter. That is in brief about Mr. Pradeep John. Sir, a very hearty welcome to you.
Thank you so much for the
It's
speech.
indeed a
Thank you.
pleasure to have you on board and all of our children listening to you from Hindustan International Schools. To begin with, I will shoot a few questions on behalf of everyone us here, and then the children will take over. And I think the basic question which all of us want to ask is, how did you become the weatherman? What interested you in taking up this very different path?
See, as you rightly said, everyone have their own passion. Someone want to become a painter. Someone want to become a food blogger. Someone will be interested in traveling. So each one will have their own interest. But the destiny is not that you have to get to work in the same field. So everyone at one point they will be going to office at morning as 8 o'clock, and I have to come back at around 5 o'clock. So there is a routine mission like life which comes. But what happens is at some point when you take up your passion and do what you like, so that time doesn't matter whether it is 7 o'clock, 8 o'clock, or midnight, 1 o'clock, or 12 o'clock. You don't think about time. So you love what you do. So that
Pradeep,
is
sir,
what
sorry.
I think.
Yeah, there you
You're good
are.
to go,
Now,
sir. Yeah,
That's
you're good
good.
to go,
That's
sir.
great.
Thank you.
So I think, sir, you'll have to begin all over again. What is the story, mystery, history behind the creation of the Tamil Nadu weatherman? And look at the smiles on all our faces looking at you.
in simple terms, I think it's Saturday evening. I don't think it will be smiling.
No, they are
So
actually they are
anyway,
looking at
see,
you.
So yeah, see, just I was saying, when you do something which you love, success is destined to happen, because you don't mind the time, you don't mind your body. So all you love is to do, continue your work. So that's what happens when you start blogging about weather. So it will be raining. If you take Chennai, there is a different kind of weather pattern. There is a hot weather season, the rainy thunderstorm season, then followed by the monsoon season. There is something which is happening one day or the other in the state. So we continue to monitor it, continue to love it. So the first thing which you do after getting up is seeing what happens. There is a chance of rain today or not. Which are the places which are likely to get rains? So this is our passion of tracking rains. From childhood, whenever it rains, maybe in the school also, whenever the new classes open, I will start. I will go early and I will just start and uh, go and sit near the. I did my schooling in SBOA, so I used to go and sit in the seat where there is a window, and so that I can see the clouds. So even in the free time or during class time also, that's that much how I love the rains, and also the water drops falling from the roofs. Small things which gives you joy. So watching rains gives me a lot of joy. That releases a lot of stress. You don't mind seeing what is happening around you at that time. So this is my journey from 1999, and then in 2008 and 10, we learned that there is a, unlike the US, there is not a strong weather blogging community in India. So there was a blogging community called Kia Weather. So we got together, and from 2014 we thought, okay, why not? There was rains happening at many places, but people are not. Unless the rains are heavy in Chennai, it never comes in news also. So why not start a FB page and then give record the rainfall which has happened, how it is going to rain, how the rains are going to happen. People wanted only three things: when the rains will start, when the rains will end, and whether there will be floods or not. So only these three things mattered for the public. At the same way, I wanted to educate them also by mentioning. So all my posts will have a pictorial explanation, why it is raining, how the winds are happening, how the winds are converging, so that at one point people themselves can start tracking weather. So this is how my journey has happened. And then 2015 floods changed everything. So before that, I was an unknown man. Even if I post something, I don't think even one or two people will see the post. After the 2015, it's changed everything.
I think Pradeep, as you rightly said, sometimes destiny is so strong, even floods can inspire you to make something big out of you. And I think that it started with a little droplets of rain and goes up to the floods and then creates somebody like the Tamil Nadu weatherman. But I'm still intrigued to know, when you love to watch the clouds, when you love to watch the rains, did you not have any kind of inhibitions, or did you not have any kind of, warnings or something like from your teachers and parents? Why are you distracted? Why are you going the other way when nobody else is going that way? Did you have any of those kind of
I used to send, maybe after the college days, I used to send SMS. So once the mobile revolution came in, so I used to send SMS, today there is going to be rain, or today there is not going to be. So I used to send. Some people will call and even think today there is no rain. Some people. So it started like that. Even the persons in your family also, they will start teasing you. So unless, as I said, the 2015 floods changed everything. The opinion. Now it's with the people when they do something. Yes, so it all takes time. So till that period, everything will look like, oh, why I'm doing this? Because as I said earlier, when I started this page and we're updating the rainfall and other data, for almost a year, maybe not even 20 or 30 people would have watched my posts. So, but I continued to do what I was doing at that time. So now the same people who have questioned me 10 years ago, they ask whether it's going to rain next week.
A bit of a cloud, and we ask, is it going to rain? We've all promptly go to the Facebook page of the Tamil Nadu weatherman and check, is it going to rain? Has PJ said something? Has he predicted something? All of us are there on that page. Amazing journey. And I think all of us have a wonderful lesson to learn from, is not to give up. No social media handles at that time, no mobiles, and just by a little observation and the deep interest that you had has brought you here today.
Small things. To be honest, there was a Hindu. I used to read, even as a kid, 5th standard, 6th standard, I used to read the Hindu newspaper a lot in those days. Those days, there was in 90s, there was not much internet connection at home. So the small satellite imagery which comes in Hindu newspaper. The small things of rainfall places, which are the places which get heavy rainfall. They used to update in Hindu those years before 2000. They used to update all these things. These small things triggered. So I will be waiting for the next day just to see how the satellite image will look. These days, it is all in the click of button. So these small things triggered that how the clouds have moved 24 hours later. Now it's all every minute, every 15 minutes, every second we can track the satellite, the clouds and other things. So I hope the session is helpful for some of them. Maybe there was none for me to teach all these things, how the clouds happen, how the winds happen, how to read a wind bar, what is the wind direction, what is the low pressure, so how it rains in the southwest monsoon low pressure, how it rains in the northeast monsoon high pressure. So hopefully I will be touching all the areas. I try to finish it at the earliest when being Saturday. Maybe after that we can have a Q&A section.
Definitely, sir. But one thing is definitely along with your BE in computer science and all that, keeping your interest alive must have been quite a crucial and hard journey, if I may say so.
Yes, it's consumed a lot of time. Maybe after marriage also, I used to sleep at 2 o'clock, 3 o'clock. So document all these data. So documenting the rainfall is also one of my passion. And visiting these places, each place before I pass away from this world, I want to visit all the heavy rainfall places. So 10 years ago, I started the journey. Every year I used to travel these very, very rainfall places. Even I visited Cherrapunji also. I visited in Tamil Nadu, same way in Kerala, Karnataka. So each year I have been going one place or another. So documenting the rainfall also creates how it rains. So while it rains, how the place will look like. So hopefully I'm also planning to maybe at a later stage a book about all these very, very heavy rainfall places also.
Definitely, Mr. Pradeep John. I'm sure you have something to share with our children. So I leave about the next few minutes for you so that you can share what you have, and then we come back with a horde of questions.
Okay. Thank you so much. Before I start the PPT, I think will there be a question in between, or after the PPT there will be a question and Q&A
session? I think let's get going with the PPT. I will tell the children to keep their questions on hold, and once the PPT is over, we will have the questions coming up. So that there's. Yeah, there we are. We are coming. Yeah.
Is it fine?
Yes, sir. Absolutely. Absolutely.
Sorry. So we'll start here.
Yes, sir.
So I think many of you will be knowing how the rainfall happens. So I will just start in brief what kind of rainfall we happen. So most of the experience I will link it to the Chennai and the Tamil Nadu climate also, if possible. So as you all know, the basic things for a rainfall to happen is the air particle to be uplifted. So whenever the air particle gets uplifted, so what happens at one point, there will be a condensation happen. So this is the basic thing. So there are three ways the rainfall gets, the moist air get uplifted. That is, one is either through a natural barrier like mountain. So whenever the areas like Kerala, Karnataka, the west coast of India, they get rainfall on this pattern when the winds, the southwest winds get uplifted through a mountain, and then condensation happen. At the same time, the other side, the Tamil Nadu will be completely falls in the leeward side, and it will be dry and not as wet as the Kerala or the Karnataka side. So that this is how the rainfall, which is the monsoon rainfall, which is happening in Kerala and Karnataka right now. So one side you can see a dense thick forest, the other side there will be a the dry and barren land. So the other thing is the frontal rainfall. Whenever the hot air and the cool air mixes, there will be an instability which creates, and then the colder air from the warm air, what happens, it uprises, and then condensation happens. So this kind of rainfall happens mostly in America. You would have seen sudden twister and tornadoes, but not in India, because the Himalayas mountain blocks the cold air coming down, and so mostly this kind of twister and tornado happens in as you've seen in the Arctic, whenever the Arctic low dips, or polar low dips in the American region. So that is why in India you don't see twisters and tornado common. So there are happening, which happens in Odisha and West Bengal areas, but it is not a common event like in America. The third one is the convective rainfall. you are very familiar with this convective rainfall. So right now, whatever Chennai is seeing in the month of May to September, it's a convective rainfall. So at the morning when you go to the school, there will be a bright sunny day, and then by the time when you come from your school or office, you will see rainfall happening. So what happens is during odd day, the warm air rises at one particular point, it can't hold moisture, and then condensation happens. So during the months of June to September, most probably in Tamil Nadu, the leeward side of the region, this kind of typical rains happen. So for the rains to happen, the warm air has to be uplifted. So that is the basic thing. The other one is the important thing is the sea breeze. I don't know how many of you are tracking my posts on the thing. I often see the sea breeze is a very crucial thing. It's a circular motion event which happens. So after a warm day, what happens? The land gets heated fast. So this is also typically what happens each day. Even the past few days in Chennai also, the similar kind of people. We are near the coastal area. So after a warm day, what happens? The land gets heated fast. So always the land gets heated fast and also gets cooled fast. So once the land gets heated fast, what happens? There is the sea temperature will be around, assume the sea temperature will be around 28 to 29 degrees Celsius. And then the land temperature goes beyond the land and air temperature goes beyond 33, 34, 35 degrees. So when there is a difference of around 7 degrees, the pressure gradient shifts, the heat flow forms in the land side, and the sea breeze starts moving in. So I think the students in the Hindustan college or the school, you would have get the sea breeze. You're close to the sea. You would have got the sea breeze first, and then it travels interior part of the city. So what happens is when it comes down, it brings lots of moisture. So most of the Chennai rains after a hot day in the evenings, you can associate with the sea breeze. It plays the crucial role of bringing the moisture and meeting with the incoming cloud. I will show this. This is I don't know how many people can get this. You can see the winds are coming from west. So during the southwest monsoon, we often see the winds are from the western side, and then the sea breeze after, you can see after a hot day, it moves from after 12 o'clock, 1 o'clock, it starts to move from the sea side. So when they meet, when the winds from the westerly side and the eastern side meets, what happens? The wind convergence happens. At that time, the clouds form and then rainfall happens. So sea breeze is very, very crucial for the convective rainfall or the summer rainfall, which happens in Chennai from June to September. So this is a typical radar picture. At one point, you can see here, this is the Tata mountain. This center portion is the Chennai. The center circle is the Chennai city. The other side is, one side is the Bay of Bengal. The other side is the land side. You can see the mountains, in mountain areas near the Tada and the Tirupati. So all these places get the clouds formation. So even in our area, these mountains in Vellore, Tada region, all are very crucial for rains, the summer rainfall which to happen. This is another typical image. This is a surface. This is a wind. You can see the sea breeze coming from the seaside, so right over the Chennai, and then the winds from the west and northern side. So when they both meet, what happens? Convergence happens. At that time, rainfall will happen. So many of you will be wondering how the rainfall is predicted worldwide. So see, right now the rainfall is predicted through numerical weather prediction. So the models are all the same. People will be having doubt in America and Japan. What second they are saying exactly it is raining. I want to say that the same computer models, supercomputers are predicting for Chennai, Tamil Nadu, or India also. So they're all interconnected. They happen. So each information is fed. Like you can see that these are the informations like water vapor, winds, everything from satellite. So the grid-wise, the Earth will be divided into grid-wise. So each grid-wise data will be fed into the the supercomputer. It will then run, and then it will suggest what kind of rain is going to happen, whether it's going to be dry, whether it's so various parameter output will be then shared in the numerical weather prediction. So you can see here grid-wise, the Earth will be divided into grids. These grids will feed into the data from the monsoon. The outputs are shared. So the output will be rainfall, temperature, humidity, pressure, sea surface temperature. There are thousands of output variables which are available in the OpenNet itself. So this is one of the output model from our IMD Met department. This is how the rains will be predicted. So once you feed all the data collected from the data, the output comes. So we can see here rainfall is shown in the interior and the coastal side. So this is a 24-hour precipitation chart. This is another models which is India has. So you can see here along the coastal areas where the entire Chennai, India is dry. Near the Chennai portion, there is some rainfall happening. Temperatures also we can see. So all the parameters. So worldwide we can see the parameters being shared, and then we have to interpret data. So computers, they will give data, but finally the end interpretation, whether the rainfall will happen or not, whether the probability of the event occurring, all these things comes to the interpretation level. You can see here, this is also one of the charts. Now coming to our northeast monsoon. I don't know how many of you are aware of the intertropical convergence zone. So it is very crucial in deciding the summer monsoon as well as our northeast monsoon. The summer monsoon is nothing but the southwest monsoon. Here the powerhouse, you can see the ITCS. ITCS is nothing but the intertropical convergence zones where the northern hemisphere winds and the southern hemisphere winds meet. So you can see that in this July month, we can see the ITCS line up to the Himalayan levels to the north of India. So you can see the winds that is near the Madagascar 1026. You are seeing that Vaisobars, that is the high pressure area. You can see winds from there. It is diverted towards the Somalia. From there, it gets deflected and comes as southwest monsoon winds. So when the ITCS moves up, what happens? The sun it moves wherever the sun moves. So it is not when during the winter season, sun moves down to the southern hemisphere. Automatically, the ITCS also shifts down there. You can see here. This is during the winter, January month. We can see here the powerhouse here is the Siberian eye. So for in the month of October to November, the driving wind is the Siberian eye. We can see in the Mongolian desert. So that is why it pushes off the cold winds and it comes via Indochina and comes as from the northeast direction. That is why it is called northeast monsoon. You can at the same time you can see the ITCS. It has fallen down below the equator to the southern hemisphere. So this is ITCS shifting down. So when the ITCS starts to shift down during the month of October to November, the convergence rightly falls over the Tamil Nadu region. So it slowly comes down. When it comes down close to the Tamil Nadu region, that is the time when the northeast monsoon onset happens for the Tamil Nadu region. So out of India, the only dependent state on the northeast monsoon is the Tamil Nadu state. You can usually find out the intertropical convergence zone with the satellite imagery. You can see a line of clouds. If you zoom in the satellite imagery to the worldwide net, we can easily find out where the intertropical convergence zones lies. So this is the southwest monsoon. As I already told you, the powerhouse is the Mascarenan eye near the Madagascar. From there, what happens? The wind comes towards the Somalia side. From Somalia, it gets deflected towards the western part of the west coast of the India. So you can see here, so difference between the July, this is how the monsoon season, and difference between the wind pattern in July and the wind pattern in January. Don't want to go much deeper into. Maybe I can clear. So this intertropical convergence zone, we also call it as the monsoon axis also. You can see some the monsoon axis is right from the Jacobabad in Pakistan. That is where the heat low lies. Before the monsoon start, what happens? The India gets heated up a lot. So whenever the land gets heated, automatically the pressure drops. The winds are sucked towards the low part. So that is how the concept of monsoon. So for monsoon to happen, the months of April and May are very, very crucial. You can see here, I think break monsoon is too early for you kids. I will just skip these slides. During southwest monsoon, what happens is normally a low pressure forms. Most of the time, a low pressure. And during the months of June to September, whenever the news person reads Vangakadalil Kaatru, a low pressure has formed, it rarely gives rains to Tamil Nadu. So what happens is, you can see here, the convection is always close to the Andhra Pradesh or Odisha part. And then the other side, Kerala side, you can see active wind clouds. So this is a very active day. The other side, you can see Tamil Nadu is completely clear. The winds are completely blocked by the Western Ghats. So the Western Ghats blocks the entire moist winds, and then very heavy rainfall happened that in the western side of the mountains. So this is another typical portion. You can see here a monsoon low which happens in the north of Tamil Nadu, close to the Odisha North Bay of Bengal. At the same time, you can see a monsoon side. So what happens is, very rarely to the months of June to September, Tamil Nadu gets rainfall, direct rainfall from monsoon. For us, it is always the Vepasaltam rains. So out day, the evening and night, there is a thunderstorm. Heat or miss thunderstorms which happens. You can see how the monsoon winds is driven. So whenever a monsoon low forms in the other side near West Bengal or Odisha, so what happens is it puts up the winds from the other side in the Arabian Sea. This is how you see often very heavy rainfall happening the Bombay side or the Gujarat or the Karnataka or the Maharashtra coasts. This is the typical monsoon low. So this is it is today's image. You can see here the monsoon low which is happening close to the North Andhra.
Children, I think there's a slight technical glitch. Mr. Pradeep seemed to have missed it. We'll just wait for some time. Mr. Pradeep, are you there? Children, are you able to hear him?
No, ma'am.
No, right? Okay, we'll just give me a second. Give me a second. We'll get in touch. You know, technical glitches happen to all of us, right? So just wait. Give me a second. Mr. Pradeep John's laptop is just restarting again. So just give him a few seconds and he will be back. You know, these kind of things happen to all of us in classroom. When we have technical issues, teachers have technical issues, and we've been through this for a year and a half, right? So it's okay. And in the meantime, I hope all of you are kind of reading the images that he's been sharing.
Yes, ma'am.
So just make note of it. Make some nice questions for us to ask the weatherman. Nice, interesting questions you must have, okay? How many of you follow him on Facebook? Or on Twitter? Or on Instagram? Ooh, I can hear some sound of a kind of a thunder.
Ma'am, it's from Vasant sir's mic.
Really? Vasant sir? Wow, Anu Varghese ma'am says she follows him. And a lot of us, in fact, as I said, a speck of cloud and all of us start following. Yeah, we have Shan telling us my mother and father follow him. Brilliant. I think many of us teachers also follow him. Teachers, I'm
Ma'am, my mother follow sir.
Nice, Aditya. Very nice to hear that. I think many of us, teachers and parents, all of us follow because we're quite keen to know. I think sir is back.
Okay.
Right. How many of you love the rains, by the way?
Ma'am, me.
Okay, many of us.
I do. Ma'am, me, ma'am.
Wonderful.
Ma'am,
I
me
think
too, ma'am.
super. How many of you feel like writing poetry when it rains?
Ma'am,
Writing a
sometimes. Ma'am, sometimes.
Really?
Yeah.
Shan, everybody likes to write poetry during a rainfall. That's something nice to hear. I would have had so many poets. Do you write? Shan, do you write?
Ma'am,
It depends on the kind of rains. Interesting. Okay. How many of you like to watch the rains with a nice hot cup of coffee?
Ma'am, my parents will not allow me to drink coffee or tea.
You don't have to have coffee. You can just have a hot cup of chocolate Black
No,
chocolate?
ma'am, that also not allowed.
Brilliant. What about the other children?
Only milk, ma'am.
Okay, how many of you just
Ma'am,
love to watch the
ma'am,
rains?
I really like the rains.
I do love the
Ma'am, me,
rains.
ma'am.
It makes me write a lot of poetry. I love to watch the music. And there's someone asking, ma'am, may I know what is sir's Facebook page name? It is Tamil Nadu Weatherman. Okay, give me one word, children. What do the rains remind you of? When you look at the rains, give me one word. No talking, just type it out in the chat box. One word which comes to your mind when you see the rains.
Peace.
Friendship. No talking. Friendship, water. Okay. For me, it's happiness. It's cheerfulness. What about the others? Ice cream. Wonderful. I welcome the teachers also to put in their words. What word comes to your mind when you see the rains?
Ma'am, you are muted, ma'am. You are muted.
Yes, son, I muted because I got a call. And the weatherman is back. So everybody's expressed coffee, pakode, beauty, rains, and friendship. And then we welcome blessings. Anita ma'am says blessing. Wonderful.
Where's sir?
We're just waiting. He says he's in. Mr. Pradeep, are you in? Yeah, Susan ma'am says playing with paper boats. How nice. Sweet smell of soil. Very true. That's what is called a. I mean, the pluviophile loves that. Playing football. Mr. Pradeep, are you in?
I think
Yes, there he is. Yes, sir.
I have a sad screen. Is it visible now?
Yes, sir. It is. It is. It is.
Sir.
So basically what happens is whenever a low pressure forms in during the southwest monsoon in the month of June to September, so we normally don't get rains, and most of the rains happen in the core monsoon areas of Odisha and other time. On the other side, in the west coast, we can see heavy rains happening in the Kerala side. So the typical rain. So between June to September, you always remember that we always get convective rainfall, and direct monsoon rainfall or direct rainfall from the low pressure very, very rarely happens. So this is the monsoon low, which is right now forming today. You can see the date also, today's chart. You can see a circulation which is happening close to the areas of North Andhra Pradesh and Odisha. At the same time, you can see the wind flow directly. You can see over Tamil Nadu. You can see the wind flows are very streamlined, straight winds. You can see the straight winds. So this kind of patterns. So once the low pressure forms, our rainfall are a little bit like monsoonish, drizzlish rains, and the convective rainfall starts to reduce. So before formation of the low, we always places like Chennai and Tamil Nadu, like yesterday we got rains, the day before yesterday. So our crucial days are before forming the low pressure, we get rains. So once the low pressure forms, what happens? Our rains will reduce. At the same time, the rains in the west coast and the areas close to the low pressure will get rains. So you can see this is yesterday's image. You can see here before formation of day before yesterday's image. You can see the low pressure is not yet formed. There is no circulation near the Odisha or Andhra coast. At the same time, you can see the wind. It is coming down from the northern side and converging close to the Chennai areas. So this is how we get rains. So most of the times before low pressure. So whenever you get a news announcement, வங்கக்கடலில் காற்றழுத்தம் உருவாயிருக்காரு, ஒரு காற்றழுத்தம் new low pressure has formed in the months of June to September. You can well assure that very, 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 very rarely, once in 20 or once in 50 years, I'm not sure. We very rarely get direct rainfall. Only the convective rainfall we get it at the evening or the night time. So coming to the northeast monsoon, so I will go a little bit fast. I know it is a boring topic for those who don't have interest. You can see the Mongolia, that is our powerhouse, the Siberian low. So you can see the Siberian low in the months of June, October to November. It pushes off the cold winds. The cold out winds comes via the China Sea and then enter into our Andaman Sea in the Bay of Bengal. So what happens when it comes here, it meets with the warm, moist air. At the same time, you can see low pressures forming and then cyclonic storms also forming. So during the months of June to September, we get only the monsoon lows and monsoon depression. There is very rarely cyclones forming in the month of June to September. But at the same time, from October to November, all our rainfall, or like you will witness cyclone Varda or cyclone Gaja, cyclone Oki, you will see between the months of November to December or October to December, most of the rains are associated with low pressure rainfall or the cyclonic storm rainfall. You can see here, this is how the powerhouse, the Siberian eye, which acts as a powerhouse for the northeast monsoon. For the southwest monsoon, I've already told, is the Mascarenan eye near the Madagascar. So this is how it forms when the low pressure, when it comes close to the ITCH line, new easterly wave will form from the tropical storm. So most of the times during the northeast monsoon, this kind of pattern will be happening. And during the northeast monsoon, it is the coastal areas which get there. So this is a typical image of a monsoon low in the northeast monsoon. We can see the low pressure area in the northern side of the winds. You can see the convergence which is happening. You can see the wind all diving together and near the coastal areas. So Chennai, Kadalur, Nagapattinam, all these places will get very good rainfall during the months of October to December period. At the same time, the interiors will not get much rainfall during the northeast monsoon. You can see here a typical low pressure during the month of October. We can see the low pressure is clear of clouds, and the northern side is having dense clouding. This is a typical area. As I said, during the months of October to November, you can see the coastal areas get more rainfall because, as I said earlier, the convergence most of the time happens in the early mornings, so near the seaside. So when you start to the school, automatically the rains will stop. So you whatever you can wish, the nights will be heavy rain, but by the time 8 o'clock or 9 o'clock happens, automatically the rains will come down. Again, during the midnight and the early mornings, the rains will again peak. So during the northeast monsoon, it is always the night and early mornings which are the very ideal term for convergence to happen. And when the sun comes out, automatically the rains will tamper out. Again in the night, the rains will start. Except in the cases when there is a cyclonic storm nearby, you get rainfall throughout the day. This is a typical low pressure and the clouds associated in the northern side. You can see here the Tamil Nadu coast, Chennai, Nagapattinam, Kadalur, all these places getting good rainfall. As you go into the interiors, you can see the rainfall amount is drastically reducing. And the areas like Krishnagiri near Bangalore or the Salem, all these places get very less rainfall of up to only an average of around 200 to 250, 300 millimeters. At the same time, near the coastal belt, you can see the Chennai to Nagapattinam, the rainfall happens around 600 to 700 millimeter on average. And I think you would all know about this El Nino, La Nina event. I will just rush through all these things. So many of you during the floods, 2015 and the cyclone, you would have got El Nino cyclone is going to come. All these things, fake messages you would have seen, or your parents would have seen. So El Nino is nothing but an event which happens once in 6 years or 7 years. So it is nothing but this region in Pacific Ocean, when it cools down, you all know that the sea surface temperature will be around 27 to 28 degrees. When it cools down below the normal of by 1 degree, we call it as La Nina. And when the sea surface temperature in the Pacific Ocean, in the dateline region, it increases by 1 degree, we call it as El Nino event. So based on the sea surface temperature, there is a large impact which happens. As you all know, this is a 3-point Nino region. You can see what happens. As I already said, whenever there is a when it warms up, what happens from Peru to the Central Pacific. So the winds are always attracted towards the areas which are always warm. You can see in the top picture, this is a typical normal wind pattern which happens during the monsoon. The winds you can see flowing from the Pacific towards the Indochina, and it will come towards the trade winds comes towards the India. But what happens during El Nino? What happens? The opposite happens, because the other side near the Peru to the Central Pacific, it is much more warmer than the normal. The winds are attracted and move to the other side. So most of the time during the southwest monsoon, the other parts of India have faced droughts because the trade winds are not coming towards their side, and it's moving the opposite side. So most 90% of the droughts in India have coincided with the El Nino event. There are a lot of indices there to track daily basis also what is a El Nino event. You can see 2015 is a El Nino event, 2097 is a El Nino event, and 92. So once in 15 years, a big El Nino event happens, and then once in 3 to 4 years, a small El Nino, a weak El Nino event happens. So here you can be, you're wondering, in 2015, how come it turned into a flood when it was El Nino event? So El Nino event basically affects the summer monsoon. At the same time, during the northeast monsoon, whenever El Nino comes, we often see floods in or more normal rainfall in the for Tamil Nadu during these years. So be it the 1997 or the 2015, it coincided with the El Nino event. You can see here the El Nino rainfall, a small green patch in the southern part of the India. So during October, you can see that during June to September, it is a dry phase. But the same way, the opposite happened in 2015. During the months of October to November, December, we got very wet rainfall season. So El Nino, the summer monsoon, it doesn't, we on always end up in the other side, negative side, while our northeast monsoon, which gives most of the rainfall for Tamil Nadu, we end up on the very, very wet side. This is the concept I said, how the convergence happens. We'll skip this, a little bit complex. Then there is another pattern. So right now you understood how sea surface temperature increase in Pacific Ocean influences the rainfall in India. At the same way, there is another thing called Indian Ocean Dipole. So whenever the sea near the Indian Ocean near the Indonesia is warmer, we call it as a negative IOD. And whenever the sea portion which is near Somalia, it gets warmer than normal. We call it as a positive IOD. So when it is normal, this is, so you can see in 2019, it was one of the strong positive IOD year. That time during our northeast monsoon, cyclones, close to 4 to 5 cyclones formed in the Arabian Sea, while the Bay of Bengal was hardly 1 or 2 cyclones formed. So in 2019, whenever there is a strong positive IOD is there, you see Arabian Sea active, filled with cyclones, while the Bay of Bengal is calm. At the same time, when there is a negative IOD, the opposite happens. Bay of Bengal will be filled with cyclones, and Tamil Nadu gets good rainfall. So this is how the monsoon winds, as I earlier said, how the winds travel, your northeast monsoon. So this is typically on October 15, 2019. We can see northeast winds crossing the Indo-China and coming to via Andaman to the Tamil Nadu coast. So another one thing is the MJO. This is a very, very critical planetary wave, which is very important for our rainfall. So MJO is nothing but Magellan-Julian oscillation. Whenever, be it whatever IOD or ENSO or whatever it be, but without MJO, the monsoon is tend to get to failed. So MJO is the very, very crucial wave, equatorial wave, which circles, which comes in a circular motion of for 60 days. So it is whenever MJO comes into Indian Ocean, we get enhanced rainfall. Whenever it moves from a west, the rainfall reduces. So without MJO, you can see here, this is an MJO. Without MJO, monsoons have failed. Our northeast monsoon example, for if you see 2000, this is a 2015 rainfall. You can see the blue colors are indicates the presence of MJO from October end till December 2nd week. There was MJO was there in our basin. We saw enhanced rainfall and floods which happened in the year of 2015. At the same time, this is the year 2016. We can see here MJO was hardly present. So there was no MJO which came into our basin. So whatever be the scenario, without MJO, the 2016 was a monsoon failure. Automatically in 2017, we ended up in water problem in Chennai city and as well as in other parts of Tamil Nadu. So MJO is a very crucial planetary wave which circles from right. It has 8 phases, right from 1 till 8. So you can see here the phases 2 and 3. So many times I would have put in my post, MJO is in phase 2 and MJO is in phase 3. So whenever MJO comes into a basin in phase 2 or phase 3, it gives enhanced rainfall. This is a typical nature. We can see here when MJO comes in automatically we can see the phase 2 and phase 3 and almost phase 4 also you can see good rainfall, and most of the cyclones which happen coincide with the MJO. So MJO is very crucial for cyclone intensification also. There are tools, many tools available to check. You can see here number 1, 2, 3, 4, 5, 6, 7, 8. You can see the movement of NJO presently, where it is, how strong it is, all these things. We can see using this diagram. There are many tools which are available. I can go. So in advance itself, we can know whether MJO is going to come into our basin or not, how the monsoon. So there are various tools are available also to track the MJO presence. So we always remember during whether it is northeast monsoon or not, this MJO planetary wave is very, very crucial for our monsoon rainfall. So we can also use the velocity potential to understand. So the green color phase is the very active phase of the MJO. The brown color phase is the suppressed phase of the MJO. So there are many tools available in the open net where we can know daily basis where exactly the MJO lies, how strong it is, all these things we can note down. Next comes to the cyclone steering. See, we all know that suddenly cyclone comes close to Tamil Nadu, and then at the last moment you hear the pressla solvanga cyclone disai mari vera engiyo poiduchu. The cyclone have changed the track. So what is a cyclone? Cyclone always traverses around a high pressure. Cyclone nothing but a low pressure. Assume cyclone என்றது ஒரு பள்ளம், ஒரு பள்ளத்துல இருக்கும்போது நம்மளே ஒரு பள்ளத்துக்குள்ள இருக்கோம். We can traverse only around the edge of the மேடு பகுதி. The மேடு is nothing but high pressure. So the cyclone will always try to traverse along the edges of a high pressure. That is how we call it as cyclone steering. So normally during a monsoon, you can see here the low pressure which is forming close to Tamil Nadu. Automatically, what happens whenever here in this case a western disturbance which is dipping up from the north, it will what happen? It will not allow the low pressure come close to the Tamil Nadu coast. It will drag it away towards Bangladesh or Burma. This is called this is one of the options where many of the times during the northeast monsoon, the low pressure will form. However, it will struggle to move towards the Tamil Nadu coast. These are the example how the cyclone traverses around the high pressure areas. You can see here, this is one of the typical image. Most of our cyclones are steered by the Pacific high pressure. So you can see one steering ridge. Steering ridge is what I meant, the high pressure. You can see one curve which is coming from the Burma towards the Bangladesh side. So what happens? The cyclone comes towards it and it will drag towards. In this case, the cyclone will move up towards the Bangladesh side. You can see here how the cyclone, there is two ridges which are happening, and then a cyclone is caught. The one other ridge is from the Arabian side, one ridge from the Pacific side. The cyclone is caught in between. Last year, you would have known that there is a cyclone Burevi was there. So I think many of you would have known about the cyclone Nivar. But after cyclone Nivar, in the first week of December in 2020, we got cyclone Burevi. Burevi got stuck up near between the ridges in the Gulf of Mannar region. So almost it was not able to move either side. So two sides there was the high pressure, the ridges were there. So it was not able to move there, and it got stuck there and got weakened. This is one of the typical example how the cyclone gets caught between the two ridges. This is cyclone Gaja in 2018. So how the ridge changes happen. You can see here the circle which is happening. This is a circle which is happening here. So this is the Burma, the Pacific ridge. This is the Arabian Sea ridge. So you can see here the cyclone which came here, it came up to this point. What happened? This ridge started to move away. It let go of the steering. Automatically, the cyclone got under the steering of this ridge. So what happened? This ridge, it circled around here and it crossed the delta. That is how the Gaja steering, the cyclone from the north of us, it came and crashed into the delta portion. So this is the typical path of how Gaja moved. The steering change. There are many other portions. We see often strong cyclones which is forming, and then the next day you would have heard announcement the cyclone has weakened. So the cyclone needs three things: sea surface temperature. The sea surface temperature is ideal about 28 to 30 degrees. So it needs. At the same time, there is another called wind shear. I think many of you know the term wind shear. It's the difference between the wind speeds between certain heights. So when you go in the flight, you often see turbulence. So when the flight is getting down, there will be different wind speeds at different heights when an airplane is flowing. At the same time, when the aeroplane tries to come down, what happens? You see this turbulence which is happening because there is differential winds. So the higher areas, the high areas will be having less winds when the aeroplane tries to come down. The wind speed will be much higher. So automatically the turbulence happens. At the same time, high wind shear is not ideal for, it is one of the enemies for the cyclone. It will kill us, very strong cyclone within few hours. Another one is the dry air. So what happens whenever the cyclone, there is always an inflow and outflow. So when the inflow of winds is filled with the dry winds, you can see here. So automatically what happens, the cyclone will cease to exist and will weaken and lose all the moisture. You can see here one of the sheared cyclone. This is cyclone Nada, which crossed the Kadalur Nagapattinam belt before cyclone Varda in 2016. We can see the circulation alone, the high portion, but it is completely sheared off the shell. Only the skeleton is there. There is no top clouds. You can see a typical image. So our strong cyclone, within 4 to 5 hours, you can see the right side picture completely sheared off. This is also another cyclone. So this is another example of a cyclone, how it is completely sheared off. I will skip all these portions. I think I'll go to the land and sea surface temperature. I think you can see here, many of you would have heard about the global warming and other things. You can see in 1900, the seas have now the temperature in 2020 is almost close to 1.8% high. As I already told you, even a small minute 1 degree increase in sea surface temperature will result in a La Nina or a El Nino event. So what happens from the last 100 years, almost there is a 1 degree increase in the land temperature is seen in the earth. You can see here at the same way in India also, if you see the mean temperature was 23 degrees. Now it has increased around close to 24 to 25 degrees. This is Tamil Nadu. You can see here the mean temperature from 26 degrees, almost 1 degree increase is seen. For Chennai city, if you come into microclimate, not much change. Almost the pattern is same. So Chennai is having one of the oldest, almost 200 years of data. You can see here in the last 200 years, there is not much change. There is a variation of around 1 degree Celsius. So this was a surface temperature in the year 1884. And you can see now almost close to 1 degree rise everywhere. So right now from 1 degree rise, many global models feel that the temperature will increase 2 to 5 degrees by the end of the century. So what happens, what impact it will have? So as I already said, warm air can hold more moisture content. So the more the moisture content, more the heavier the rains will happen. You can see here, the areas near close to end by 2100, India is going to get much more better than now. But is this right? What if we are in the circle of the warm phase of the earth? Because right now we are seeing only the last 100 years of the global warming, the industrial period, because before 1800 that is not much industrialization. But what happens if it is beyond? I'm not saying denying the climate change or the global warming. 100% there is some change which has happened. But at the same time, if we go little bit thousands of years ago, we can see there is always a warm phase, ended up with a cold phase and then a warm phase. So certain, we know we are right now in the warm phase of the cycle. Somehow the nature will find again to cool the earth. At the same time, one more thing which I want to say is the heat islands. So whether the other things are true or not, this is perfectly true. We know that Chennai's surface is completely paved. You can't see sand or a green surface there anywhere. It is completely paved with roads and other structures. So what happens automatically? The heat will be reflected back, and you always, you know, when you walk in a grass, there will not be much heat. But at the same time, when you walk in a cement track, you can see the heat, the legs can feel the heat which has been reflected back. That is what happens here also. The heat will be reflected back in the atmosphere. So the atmosphere will be, the city areas will be comparatively warm than the outskirts of the city areas. At the same time, whenever you plant a lot of trees, particularly near the Gindi area, Rajbhavan area, you see when you go there, you always feel the heat effect a little bit less compared to the other areas because of the trees. So when you plant more trees, you can mitigate the heat island effects. I think I will skip all these things. I will now go to the question and session. I think I will stop my boring class here.
We wouldn't call it boring, sir, because it's been a great compilation of immense data, I must say. But looking at all the data, I don't know how much of it my children can take it all. But it's amazing to see you consolidate so
unless
many.
it is you have interest, it is very difficult to follow.
True, but this is amazing compilation of data of so many years. And I think the children are already popping up with questions. There's one question which is coming up, sir, from Rupesh. He says, sir, would you please give us your thoughts on artificially induced rain that they attempted in the US?
See, whatever rains which happen here in Chennai, artificial rains, we tried it in the 1980s also in Chennai, and it was a failure. In Tamil Nadu, it was a failure because uh, we cannot make sure. We can make the clouds form also at certain points by putting the silver nitrate, whatever that is. But what happens, whether we can, the wind direction has to be exactly same. The rains have to pass for the exact areas. So it is very difficult in an environmental like Tamil Nadu or India, where artificial rains will happen. Difficult to happen. Whatever you put it in the months of January or February or March, it is all completely dry period. When you put at that time the silver iodide and whatever to create artificial rain, it fails because there is not much other moisture support. Whenever the rains are, it is going, the rain clouds are conducive. At that time, maybe you can enhance the clouds. Other than that, when it is a dry period, entire moisture will be dry. It is very difficult at that time to create artificial rain and succeed in it. So if someone says that the artificial rain is possible to create in a country like a tropical country like India, with the monsoons and other wind patterns, it is. I don't think it is possible. It may be they can. If I am the person who is given in charge, what I will do is I will make sure that I put these things right when the rains happen and claim that it is because of artificial rains, the rains have happened. But without that, also the rains would have happened. So artificial rain is a failure in India. We have tried it much earlier, 30, 40 years ago. Also, we have tried it and it's a failure. It is impossible to create and make it rain in the exact place. It's very tough here.
Basically, it's not good to disturb nature and the way it processes itself. A very philosophical thought, but I suppose it's right, sir. We have Sri Charan coming up with his questions. Sri Charan, go ahead, son, shoot.
Yes, Mama. Good evening, sir. My question for you is...
Be a little louder, son.
Am I audible, Mom?
Yes, you're good
okay,
now. Please
sorry,
go
it
ahead.
was on
Please
mute.
go ahead.
Good evening, sir. Sri Charan Greaton. And my question for you is, how will the wind pressure differ in the equator as it differs between the poles?
I think, as a tropical pressure, there's a normal surface pressure is around 1011 HPA. That is our during in the plains. So maybe in the Arctic, it is always filled with some Arctic lows. The pressure difference will be always, there will be some extra tropical low pressures there available in the either side of the in Arctic or Antarctica. At the same time, being a tropical region for us, normal surface pressure is around 1010 MB or 1010 HPA. Hope it answered your question.
Yes, sir. Thank you, sir.
Pranav?
And the pressure differs whenever there is a monsoon season which comes in during the months of June to September. Automatically, the monsoon system itself is a complete low pressure. That is why it is very difficult. If someone had wondered why there is no cyclonic storm in June to September, it is one of the reasons is because the entire monsoon system itself is a low pressure. So inside a low pressure, another low should form. It is very difficult. We get only the monsoon low. That is why during the months of June to September, we never see cyclones. At the same time, the winds are westerlies. Cyclones always move from west to east. So cyclones forming near Chennai cannot go to Andaman or Thailand. So whenever a cyclone forms because of the Earth Coriolis force, it always moves from west to east in the northern hemisphere.
Pranav, are you there, son? You can go ahead. Well, Sir Pranav was wanting to know, how do you get the information regarding the climatic changes?
It's climatic changes means regarding what? Particular place or?
Pranav, I think you need to be a little more particular with that question about climatic changes, where and when. Okay, before Pranav could come, I think Ashita
Okay,
has a very
anyway,
interesting question.
I assume the question I will answer that. See, for a climate change to see, we cannot see that one day event. Suppose today there is going to be a very heavy rainfall event in Chennai. We should not blame it on the climate change immediately on the climate or the nature that there is some change which has happened. So climate change has to be seen over a period of 30 years or 50 years or 100 years. So how the change has happened, how the decadal variations have happened. So before 100 years, if we take for Chennai, even in the 1850s, you have got 500 millimeters of rainfall. In 2015 also we got 500 millimeters of rainfall. So with or without change, whether it is one of the nature's freak event or not, how the trend has changed, how many heavy rainfall have been happening per year 100 years ago, how many heavy rainfall is happening right now. So that is the way you have to analyze the climate change, and not to a particular place, maybe particular region we can take it to understand how the climates have begun, or whether because of some other human intervention the rainfall pattern have changed, or this decade some have decadal variations also. Suppose assume when we are kids, we often see a cyclone crashing into Nagapattinam. But if you see 2018 Gaja was the one last cyclone which came. Before that, it was 25 years ago in 1993, then when there was a cyclone. So after a gap of 25 years, Gaja came into Nagapattinam. So almost 20 years that the decadal, there was not much active phase of the cyclone. So these kind of trends we have seen. For 10 years, the cyclones will be active. Another 10 years, it will be dull phase will be there. Another 10 phase, again, there will be active phase of cyclones. So these kind of variations also there. So if you want to study a climate change for a particular place, you have to go a little bit deep, and not only, and you also coordinate not only that place, you have to coordinate with the data of the nearby places also, and compare it whether climate changes happen or some other, because of some other intervention or a power plant or something else which have industrial development which have come, because of that rains are not happening.
Sir, I have a question. This is Asoga. Okay, I'm faculty over here, and I have a question. Like recently in Canada, there is a village called Lytton. There is a sudden weather change. Like Canada means we used to know that it's damn cold. Like sometimes go up to minus 50 degree, but now suddenly there is an increase up to 50 degree. What is your opinion about that?
I think that place got around 48 degrees of temperature and break the all-time record for the Canada in 100 years. When do you see heat wave in India? Suppose when you are in Chennai. So when there is a low pressure, you get rains. When there is high pressure is just suppression of winds and clear winds. We get dry winds, and because of that, we get hot weather or clear weather. So most of the times during the months of May, you see high pressure dominant over India. That is the period when you see we get hot weather on odd days. So similar kind of weather. So when there is a low, there has to be a high pressure nearby. So nature is like that. It will be high, low. There will not be two cyclones stick together. There will be ஒரு பள்ளம் இருந்ததுன்னா பக்கத்துல ஒரு மேடு இருந்துதான் ஆகணும். அதுதான் இயற்கை. அதே மாதிரி தான் நேச்சர்லயும். So low pressure, there will be followed by high pressure. So what happened in Canada is nothing but an high pressure. They call it as a heat dome. So which blocked completely the winds. So when the high pressure was dominant in Canada, what happened? It stopped the flow of Arctic winds, the polar low winds. So normally they don't have mountains like Himalayas. When the low dips down, for us it is blocked by the Himalayan mountains. There, what happened? This high pressure is it's the ridge. It blocked everything. So continuous prolonged heating happened in these places in Canada because of this heat dome. The high pressure, or the other term is they call it as a heat dome. There, it blocked the winds of the cold winds from the north. Automatically, what happened? Prolonged heating took place there. At the same time, the temperature shooted up and went up to 48-49 degrees in Canada. It happens very rarely. Some cases we are not sure whether it is because of the climate changes happened, because 100 years ago the same kind of 48 degrees have happened, the same place, the same kind of heat, or it may be in another 50 years we are going to see, maybe once in 10 years we are going to see a similar kind of heat dome which is going to come there. So once we get weather is a pattern, everything, weather, rainfall, everything is a pattern based. So once you understand the pattern, we can know, okay, some changes happen, or because of that only, it is going to be a constant trouble. This high temperature is going to be, or it's going to be one in maybe in another 100 years, we will see another event. Suppose if you take Chennai, we have recorded 45 degrees. The highest ever recorded temperature in Chennai is 45 degrees Celsius. At the same time, the Tirupati recorded close to 50 degrees Celsius. So that is the hottest record for Tamil Nadu. And suppose if you take Chennai, this happened in 2003, May 31st, 2003. After that, we have not seen temperature crossing 44 Celsius, not even once. Okay. This happened because of the freak cyclone which moved, we took away all the moist wind and went towards Burma. So once in 4 years, 5 years, these kind of it is not a constant every day. Every year, Chennai is trying to break 45 degrees, or every year the cyclone, the temperature is increasing in a very steady speed. So that kind of change is not happening. But when there is some change and when these freak events happen, maybe they enhance them. Instead of 47 degrees, the temperature may be increased by 2 or 3 degrees Celsius. But as far as your question is concerned, it is an high pressure which got stagnant, stuck there in one place because of that prolonged heating happened, and then because of that, the entire Canada was completely warm.
Yes, thank you. Thank you, sir. Well explained. But what I thought was maybe it's a man-made disaster because some houses are burning, people are running out of the house, and they're just moving to some other safest place. Even the government is going to announce, before the government announces, the places got burnt and the people are running out of the place. So that's what I thought. Maybe it's a man-made disaster. That's what I got something like maybe.
No. See, you cannot increase the surface temperature of a particular place because you cannot block the sun rays. You cannot enhance the sun rays or anything. So it is nature based. Why it has happened is also nature. Humans cannot dictate or make a low pressure or high pressure or divert the cyclone towards particular place. So we have not evolved in that kind of technology right now. So predicting, we are only in the predicting level where the low pressure will move, where the cyclones will. We are only in that stage, and we are pretty good at that. But even before the event happened, that increase in temperature was already captured by the models itself. So though we have not expected close to 50, there was abnormal increase which was already captured even for the Canada event also.
Interesting.
Thank you.
Ashrita, are you coming up with your question?
Yes, ma'am. So good evening, sir. This is Ashrita from Grade 12 at Hindustan International Karapakam speaking. So my question to you, sir, is that there's a lot of misinformation and a lot of myths about the weather. So which is a myth or certain misinformation that was spread that you personally dislike, and how can we avoid believing this misinformation, and how do we find proper news?
If you can specify 1 or 2 myths, I can clarify that.
So there was a lot of myths during especially during Chennai floods and during cyclone times. There was a lot of misinformation about how the weather was being predicted, and there was also a lot of misinformation about where it was going to hit, how it was going to.
Well, you got to be clear about a myth or a misinformation.
Oh, it is misinformation. Sorry.
See, basically, we all know that cyclones, when you get during the disaster time, there will be 1 or 2 persons. As I said earlier, all the weather predictions are done through numerical weather models. So even now, if you see, you can see that in December and January, in the months of October and November, there will be cyclones. So the models will predict the cyclones earlier itself. We know it's a climatology that during the months, there will be some cyclone which is going to happen. Which place and all, we cannot confirm it. What happens, some persons know, there are a large number of tools are there. They take the cyclone graph. The first run itself, models, it keeps on changing as it gets data. The more we near the data event, so we can there are short range forecasting, long range forecasting, medium range forecasting. The long range is the one which goes for months. The short range, medium range is it is a 15 days to months, and the short range is we can call it as from 1 to 15 days. The short range forecasting, the accuracy will differ. So if you take the 15th day or 10th day forecast, it will be much less accurate. Maybe we can say that it is only 20 to 30% accurate. And when you come on to the 3rd or 4th day, almost it will be 60 to 70% accurate. When you are 1 day ahead, almost 95% accuracy. The probability of the event happening is high. So, but those many people know, they see these charts and websites and the designs. And then once a cyclone shows to Tamil Nadu, automatically they will put the graphics and videos on the YouTube. So, and then they say that there is going to be a cyclone which is going to crash into Chennai. But what happens is, when the day comes closer, automatically the cyclones start to move the other way, maybe missing Tamil Nadu. So during the months of April and May, it is not our, most of the time the model starts with Tamil Nadu, and then You can see the landfall area close to Bangladesh or Burma. Even in the northeast monsoon, it is our climatologically, it is our season to get rains. At that times, we can say it shows the cyclone shows Tamil Nadu to happen. It might happen 50 to 60%, it might come true. But what happens is the wind. Sometimes messages may come 200 kilometers of wind speed is going to happen in Chennai, Tamil Nadu, all these kind of misinformation. But we know that when it is a very strong cyclone, it always skips us and goes to Andhra. Steering is always favorable to move north. When it's a moderate intensity cyclone or a decent 100 to 150 kilometers, we can see cyclones crashing into Tamil Nadu. So the strongest ever cyclone to hit Tamil Nadu over 200 kilometers winds is the 1964 Dhanushkodi cyclone. Other than that, I don't think any cyclone has even come close to that of wind speed. So even Varda also, if you see, it is around 120 kilometers sustained winds. But misinformation, once seeing the charts and models, that kind of rumor is very troublesome because many people are now having access to these tools and putting immediately without the model confirmation and the consensus. There are many models there. Once you get consensus only, based on that only, you know, okay, this event is going to happen like this. This cyclone is going to cross at this speed. Even at that case, even 24 hours, if you take the last year, the cyclone Nivar, which was expected to cross with 130 kilometers wind speed. In the end, it crossed only with 60 kilometers wind speed. So nature at the end also, that kind of event will also, it's very difficult to predict in our basin. So misinformation during floods and cyclone is exorbitant amount of wind speed and exorbitant amount of rainfall. So even in 2015, it was people were saying 2,500 millimeters of rainfall is going to fall. That kind of misinformation spread because truth always spreads slow, while the fear-mongering lies will always spread very fast. That is the thing which I learned from media.
Absolutely, sir. Kishore, are you asking the next question to sir?
How do you predict the cyclone wind speed, sir?
Kishore, you need to be louder, son. You need to be louder.
How do you predict the cyclone speed, the wind speed?
Kishore,
see, for all the cyclones, you know, when a low pressure forms automatically from the when the easterly waves comes during south northeast monsoon, it intensified. It is not that immediately today itself, tomorrow there is going to be a cyclone is not going to be crossing Tamil Nadu. It's not like that. So there are many stages in cyclone. So first, the initial start is a easterly wave or a trough. From the trough, it develops into a low pressure area. From the low pressure area, it becomes depression, then deep depression. Once deep depression becomes cyclone and the wind speed reaches 35 knots, automatically what happens, IMD will give a name to the cyclone. So till it reaches 35 knots, they will not be giving names for the low pressure or depressions. So once the cyclone gets that destined speed, we know that there are what exactly is the speed in the center and the circle and the outer edges, everything can be monitored easily. So based on that, after becoming cyclone, there is a further intensification. We call it as a severe cyclone, very severe cyclone. And finally, when the wind speed reaches over 200 kilometers, we call it as a super cyclone. 220, we call it as a super cyclone. So there are many tools available to determine even for a common man like us, we can determine where exactly the cyclone is living, what is the eye wall cloud which is happening, what is the wind speed around the eye wall cloud, how dense is the temperature in the eye center portion of the cyclone. So it's all available there. When you have interest, you can get all this information. The wind speed is very easy. It is also by the models and other also satellite, other things are there. That based on that we can, when it crosses the coast, we have wind anemometers, wind recorders are there. Based on that, we can estimate what speed the cyclone have crossed. Suppose for Varda, it is 120 kilometers was recorded in our Chennai Meenampakkam airport. The case of Gaja and all, the wind speed were close to 140 kilometers.
Oh. Okay, we have the last. So we have the last question coming up from Simran. Simran, you can go ahead.
Good evening, sir. I'm from 12A, Karapakkam. So my question to you is that usually a cyclone is predicted of what path it will go through. Like using our technology, it will go through a certain path. But at times it would drift apart from its path. Like for Varda, it was go to Chennai, but it went to Pondicherry. So on what factor does this cyclone drift? What factor does the prediction go wrong in it drifts?
See, during the months of November and even we know that, as I said earlier in the presentation, cyclone steers around the ridge. Okay, the ridge is the taller portion, and the low pressure, the cyclones are the lower portions. So we know the position of the ridge. So where it going to transfer? But at sometimes what happens, there may be some slow movement which may happen. In the case of Nivar, what happened? There was 1 day delay which happened. So automatically it was not moving as fast as expected. Though we got rains, ultimately the difference, I expected it to cross close to Mahabalipuram Kalpakam belt. The Met Department expected close to Markanam belt. So, in between, the cyclone is not one point. Okay, it is sometimes if you take Varda, the center portion itself is 50 kilometers wide. It is not that one area it is crossing. So there is a northern side and the southern side. So there are chances of it going wrong by a certain degree, but not by much. Maybe 50 to 100 kilometers, plus or minus 50, 100 kilometers, it might cross the land. Not more than that. By one day, 24 hours. Technologies are available right now by the numerical models that we can pinpoint the locations where exactly the eye of the cyclone is going to cross, where exactly the highest winds are going to be, whether the northern side or southern side, where exactly the rainfall clouds are going to be. So if it is 4 or 5 days in advance, it will be around, we can mark it as 80%. But 1 day in advance, we can exactly tell where exactly, with perfection, maybe 98 to 99%, we can exactly say this is the point it is going to cross the land. I don't think in last 15 years of my trekking that in 1 day a very drastic change have happened. The rainfall location.
Pradeep sir, there's one last request. Can I please take that question?
Yeah, please.
Coming from a teacher. Vasant sir, please go ahead, and after that I think we'll have to close it because it's a Saturday evening.
I want some
Vasant,
different kind of...
Vasant sir, are you there?
Very good evening. Very good evening, sir. Actually, some 20-30 years back, we used to hear that Tingal Mummari Peiga Thiruvaram Valarga. So,
can you come again? What?
Tingal Mummari Peiga.
Okay.
Different types of actually we get rainfall. So usually when children they ask us, sir, is there any ways to just have these rainfalls and all? So we usually tell them planting lot of trees. So I want just getting an idea from you. Apart from planting trees, there are any some like techniques, because you are in that field. So you might be just guiding us very correctly. So apart from planting trees, is there any ideas where we can just predict, preserve this water and as well as we get rain also, sir?
See, you know the concept of we are a monsoon-based rainfall. The planting trees will help us to get mitigate this climate change effect and other things. Just by planting trees, we cannot attract rains. So it is one of the myths, I will say. But if you plant more trees, automatically you will get automatically the rainfall will be more. So I don't think that, because that is the case. Then there are many forests around us. Then in the forest it has to rain daily. So we are monsoon based. We are having a monsoon based climate. So we are dependent on the low pressures and the monsoon depressions or the cyclonic storms for most of our rainfall, particularly for Chennai city. But at the same time, if you often see near the lake areas or near the lake areas like Chambrampakam or Red Hills. So whenever it rains a little bit more in these areas compared to other areas. So that kind of things happen. Other than that, to attract rains, I don't think any physical structures or man-made structures to be made. What we can do is we can protect all these lakes and other things and keep it ready. So as I said, whenever rain comes, there is a good water amount of being stored. The interconnectivity of because of urbanization, we have lost all the interconnectivity between the lakes. So one lake, when it gets filled up, automatically it has to go to the another lake. But what now is that it is surrounded by people and buildings and other things. So that area gets naturally flooded surrounding that area. This is what been happening. Other than that, if you do something, people or persons, a common man or even governments or anyone, human cannot attract rains by creating some structure and welcoming the rains. I don't think, and even planting trees also. If you're planting trees, it is very, very healthy for you because of it, for mitigating the heat island effect, as well as for good for the oxygen, other things for your health, the community health. It is much good. Other than that, I don't think by planting trees you can attract rains. So that concept, I think it's a myth.
There's a myth which he has
Thank you
clarified.
so much, sir.
So
Thank you.
because of myth, don't plant. Don't
stop
avoid
planting
planting trees. Yeah, because if you even come now, even in the urban area, I have planted jackfruit tree. It took almost 15 years for me to see the fruit of it. So you can go and see daily. There's even after 15 years, I'm going daily visiting the tree. What happens? So when you grow a tree and to see it grow from small tree to a big plant, it's a good joy. So each
sense of
one of us,
fulfillment
if you
that
have
you get.
space, I know more. Yeah, many would not having space before their house, but those who are having space at least need to plant trees. It helps in many other ways, but by planting tree, it brings rains. That I will say openly is a myth.
It's a myth. Wonderful. Pradeep sir, thank you so much. We've come to the end. I know there are so many questions and so many minds, but I think we'll have to keep the time constraint in mind. I just want one final word of advice or suggestion or whatever you would like to tell our students before we close the session.
I will say the students, say this is only one life you have. There is also one life, one chance. So I know it is difficult in this kind of mechanized world to do things which you love. So what I will say to the students is always keep your passions open. Always do things which you like, which you love to do. Because when you do that, I don't think anyone can prevent that success to happen. So always do things. Even I know many people will think that I'm having a job, I'm having this. It is very difficult for me to. But whenever in the free time or thing, in order to fulfill your life, or having a purpose in your life, to please follow your passion. For the students also, please study well. But at the same time, after your studies and everything, when you follow your passion, success will also follow you.
Wonderful. I think you're exemplary for that. I mean, studying hard for a world that needs a profession and then following your passion at the same time. It's been great interacting with you, sir. And from all of us at Hindustan International Schools, thank you very much for taking time and talking to us. Out of the hundreds who join, I'm sure there will be a handful who will be future weathermen or who will create a difference on the planet by their contributions towards the ecosystem.
Don't become weatherman. Don't become weatherman. If you become a weatherman, it's a curse. It's a stress. I will not suggest you to become. Enjoy nature, enjoy the rains, but don't become a weatherman.
Okay, thank you very much, sir, from all of us. Wishing you a great weekend. And children, teachers, all of you, thank you very much. Have a lovely weekend ahead. Let's carry the message home, what Mr. Pradeep John has left for us. Thank you, sir. Thank you once again.
Thank you. Thank you, everyone.
Thank you, ma'am.